Alright, welcome back to my channel. Now in today's video, we will be revising the theme of cycles, specifically water cycle, right, using questions taken from the PSLE papers from 2016 to 2022. Let's get started. Alright, this is from 2016. Now, which of the following diagrams correctly show how trees play a part in the water cycle? So as you can see, alright, the arrow shows you the movement of either water or water vapor, and it shows you how it moves from one stage to another stage. Now, if you take a look at number 1, alright, and see if it's true. Now, what could be possibly coming down here from clouds to the trees? Possibly rain. Basically, every arrow needs to make sense. Okay, here, clouds to the river and sea. Well, it is also rain. Now, must I start from the clouds? No, I can start from anywhere on the arrow. I just chose to start from the clouds. Now, how about this part here? What happened to the rivers and water? Why is there an arrow from the rivers and water to water vapor? How did this turn into water vapor? This is liquid water. So therefore, the liquid must have evaporated. So there's evaporation here that caused the water in the rivers and the seas to turn into water vapor, which will then condense as the water vapor rises up to and touch the cooler parts of the air above. This will condense into clouds, which are tiny water droplets. So far, these few arrows make sense. Now, how about these arrows? How could trees be giving out water vapor? It can. Now, take a look at the simple diagram of a tree. Alright, there are roots here, and of course, there are branches, and there are leaves. Pardon my drawing, not the most fantastic. Now, water enters through the plants, through the roots of the tree. Travels up the water carrying tubes, travel up water carrying tubes, through the leaves, through the stem, through all parts of the plant, including through the leaves. Now, what's on the underside of a leaf? There is tiny little holes called stomata. So when the water travels all the way to the stomata, it will leave the plant, leave the tree as water vapor. This part. Now, you don't need to learn this name of this process, but it's known as transpiration. And that is the correct answer for this. Now, as for the rest of the answers, they are all wrong. Okay, basically, this arrow here is wrong. Trees do not provide water to rivers and sea. There's no way trees are like leaking water or water being squashed out somehow. Water is not leaving the tree as a liquid. Water can leave the tree as a vapor, not as a liquid. So this part is wrong, this part is wrong, and this arrow here, this part is wrong as well. Now let's take a look at the next question. This is taken from the 2020 paper. You want to pause the video and examine the question first before listening to the explanation. Alright, now setup P and Q were placed on the table. They contain equal amount of water at 25 degrees Celsius and equal amounts of ice cubes. So all these terms are important. Words are important in science. Right? Now, the beaker in setup P was wider. Okay, so this is a wider beaker. This is a narrow beaker. But all else is the same. The amount of water is the same. Alright? The number of ice cubes are the same. The amount of ice cubes are the same. And ice cube, I'm not sure what the temperature, so I'm going to assume they are all at 0 degrees Celsius. So therefore, this surface here now becomes a cooler surface. And when I hear the term cooler surface, so this one that I'll highlight is a cooler surface. So what happens at a cooler surface? Condensation. But where is the water vapor coming from? It's coming from the water. Now notice they're all on the same table, right? So same table means they're exposed to the same conditions, like the same amount of heat in the environment. Therefore, the rate of evaporation, if you remember it using these three letters, the rate of evaporation of water depends on the wind condition, the exposed surface area, and the temperature of the surrounding. Since they are at the same location, the temperature is the same. So this is not the cause of greater or less evaporation. Since they are both covered up in a container, so both the water sources here are not experiencing any wind. So this is again not a factor that causes any change in the rate of evaporation. So what is? It will be the exposed surface area. And this will be the exposed surface area. This is a narrower one. So imagine here the water is evaporating as water vapor. I'm spreading out the arrow as evenly as I can. So you can see here. Here I managed to draw 5 arrows. Here I only managed to draw 4 arrows. Which means here there's more water vapor getting into the container than this. More water vapor will then therefore touch this cooler surface, causing there to be more condensation. Here, there's less water vapor touching the cooler surface, so there's less condensation. So after a while, they say more water droplets form in P. I just explained to you, why is there more water droplets here? There's more water droplets because there's more water vapor. And why is there more water vapor? Because there's more evaporation in P. Why is there more evaporation in P? Because P has a greater exposed surface area. So the answer here is more water evaporated because the exposed surface area of the water was larger. Next one. This question is from 2017 paper. Again, pause the video, try this first. Which of the following is a possible effect on the water cycle when the temperature of the environment increases? It's a possible effect on the water cycle. Now, let's recap this. So there are 3 things that can cause the change in the rate of evaporation: the amount of wind, the exposed surface area, and the temperature. Of course, for those of you might have learned the 4th one, humidity, but humidity is not in your syllabus, so that will not be tested. So I'm just mentioning here for those who know about it, but I'm not going to go into it at all. So what's the effect on the water cycle if the temperature of the environment increases? So increase the temperature, you increase the rate of evaporation. So I'm looking for evaporation here. So evaporation increase, correct? So evaporation decreases, definitely I know it's wrong. It cannot be decreases, because when temperature increases, the rate of evaporation will also increase. When there's more evaporation, of course, just like this case here, more evaporation means more condensation. When there's more condensation means there are more clouds. More clouds means more rain. Therefore, here in this question here, there will be more rain. So answer is 3. Now, next one. Now, let's recap this one. We talked about it just now, okay? So, what's W? Wind. What's this? Exposed surface area. And what is this? The temperature of the surroundings. So, Ahmad conducted an experiment by placing 2 glass beakers, each containing 50 ml, so same amount of water, and the same type of liquids, okay, in the same room. Same room means the same temperature. So when the amount of water is the same, the temperature is the same, wind condition is the same, surrounding temperature is the same, but the liquids were kept at different temperatures. This is interesting. The liquid were kept at different temperatures. He measured the volume of liquid L remaining in each beaker after some time. Same liquid would mean that the rate of evaporation will be the same under same conditions. The difference in the condition here, remember we talked about the condition W, E, T. So right now the amount of wind is the same. The temperature is the one that is different. All right, and the glass beaker, let's take a look. Exposed surface area here is the same. So this part is the same. So this is the only difference. That temperature is different. What happened? There's less water here. Less liquid L means there was more evaporation. So at the start, there was this amount of water, liquid L. At the end, there was only this amount of liquid L. So there was more evaporation here. So therefore, this temperature must have been lower than this. This temperature must be lower than this. So therefore, the rate of evaporation in the first beaker was less. So there was more liquid remaining. So I'll be looking for a number that's less than 60. So look at the options here. This is definitely wrong now. I have two possible options. I've narrowed it down. Now let's go on to the next one. And before I continue, just remind you about rhino. So I'm sure you have learned this. So always remember to read the question carefully. All right, you got to highlight the key ideas like what I've done here. I've underlined. Okay, I've taken out some simple annotation. Of course, don't spend too much time on annotation. All right, and I'll think about and just narrow down the options. I need to identify the concepts. For finally, I need to shade my OAS. So Ahmad repeated the experiment using another two beakers with 50 ml of liquid L. This time, the liquids have different exposed surface area. I go back to my WET again. So here, this time around, this is different. What else is the same? Temperature is the same, so this is the same. All right, and they're in the same room, right? To talk about it in the same room. Therefore, wind condition is the same. Okay, let's see which one has less water. So this one has less liquid. Remember, less liquid means more evaporation. If there's more evaporation here, therefore it tells you the exposed surface area of beaker 3 must be larger than that of beaker 4 must have a larger exposed surface area compared to beaker 3 because there's less liquid left, meaning there was more evaporation. So here I should see an exposed surface area that's larger than 28. So this is larger than 28. So the answer for this is 2. A way you can see is like that, the diagram here. Okay, so before was like that. After there was some liquid. After was this. Okay, so sometimes the drawing diagram can help you to understand a situation better. Now let's go on to the next question. Now in recent years, this kind of question is more and more popular. What kind of question am I referring to? Questions that ask students to recall the definitions of a certain concept. For example, evaporation and boiling. So you need to know what evaporation means, you know what boiling means. Sometimes there could be questions like what does pollination means, what does seed dispersal means, such questions. So what's the difference between evaporation and boiling? Notice the word water didn't appear here. So don't talk about water. Don't talk about, it boils at 100 degrees Celsius. This is not about the evaporation and boiling of water. There are many liquids in the world and they can all evaporate or boil. So therefore, just talk about in general. So basically, evaporation is when a liquid changes to a gas at any temperature. Whereas boiling is when a liquid changes to a gas at a fixed temperature. Now, of course, there are other answers for this. Like some of you will talk about evaporation only happens at the surface of a liquid and boiling happens throughout the liquid. That is an acceptable explanation as well. But here, I'm just giving you one answer to remember. It's just 1 mark, okay? For those doing corrections, please pause the video and write down the correct answer. Next one is a very common question. Common as in, over the years, they have tried different iterations of this. There was a year when they replaced the fried bananas with dumpling or what you call bao, okay? So the idea is the same. So they just replace the different items inside. So let's be familiar with such questions. Fatima fried some bananas and placed 2 pieces each in box R and box S as shown below. So there's a box with fried bananas and you say hot. So there's a heat source and the heat will cause the moisture in the bananas to evaporate. What happens when the liquid turns into water vapor? The water vapor will be trapped inside the box. And when the water vapor touches the surface of the lid, the inside of the surface of the lid, so we'll draw a cross section here, alright? So let's say this part here, we have our banana, okay? And the top part is also a lid. When the water evaporates into water vapor, it will rise up, and then when it touches this surface, which is definitely cooler than the hot, freshly fried banana, right? It will condense into water droplets. And after a while, when all the water droplets start to condense and come together, it become heavy and you drip back onto the banana and make it wet. That is why the smart people who sell the fried bananas have holes on the lid. Why are there holes on the lid? So if I show you a side view, so if there's a fried banana inside this box, now there's a difference, right? Can you see the difference? The water vapor now can escape through the hole. Now there will still be some condensation on parts of the box, but this will be much less than before. So there will be very little water that will collect and they will condense here and drip back down. Okay? Now, she observed the banana in box R became slightly wet after some time, but not those in box S. Explain why the bananas in box R became wet. I have basically explained the science of it behind this to you. Let me show you the answer. It's a 2-mark question. So basically they'll give you marks for the evaporation part, the condensation part, and the dripping part. So first step to remember is remember these 3 steps. Evaporation, something must have evaporated. And the evaporated water, it will turn into water vapor. The water vapor will condense when it touches a cooler surface. And when the water droplets come together, and it will become big water droplet, and that will drip back down, making it wet. First step. The moisture is the banana, the moisture in the banana, gain heat from the hot banana. That's why it's hot, right? And this moisture, this banana is a bit moist, this moisture evaporated as water vapor. Half a mark for your evaporation to show you understand what happened inside. The next part explains what happened to the water vapor. The water vapor touches the cooler surface of box R, so half a mark for telling us, oh, you know what happened to the water vapor. It touched the cooler surface. And then, you know what happened when it touched. It will lose heat, the water vapor will lose heat and condense into water droplets. So these 2 half tells us you understand how the condensation of the water vapor happened. But that's not enough because you've got to explain why it became wet. So after the water droplets reach the top part, you need to drip down onto the banana. So the last half mark is for the dripping down. And drip down onto the bananas and wet them. Now, so we take a look at this table and I break it down for you. Ask yourself these questions. Where is the water in the boxes? Of course, it's in the moist bananas. How did the water turn to water vapor? But in any water cycle, there must be a heat source. The heat source here is the heat from the surrounding. In this case, will be the hot bananas. What happened when the water vapor touches the lid? Of course, it will lose heat and it will condense. So how did the bananas become wet? The condensed water droplets drip down. This is a step-by-step understanding of this question. Next part. Right, this question also became popular recently. There was all about spectacles. Alice and Beatrice were traveling in an air-conditioned car. Both were wearing the same type of spectacles. Alice put her hand over her spectacles, but Beatrice did not. When they stepped out of the car, there is less fogging over her spectacles, but Beatrice did not touch her spectacles. Beatrice did not put her hands over her spectacles. What does it mean? Like spectacles, put her hands over the spectacles. So like touching the lens of the spectacles. when they step out of the car, there's less fogging on Alice's spectacles. She touched them, remember? She touched them. Now, what is her body temperature? Probably about 36 degrees Celsius, 36.5. Alright, so her hand will have a certain temperature also, right? Will also be about 36.5 degrees Celsius, roughly 36.5 degrees Celsius, body temperature. So when her hand touches her spectacles gain heat from her hand. So her spectacles, Alice's spectacles, were not as cool as Beatrice's spectacles. Her spectacles is really the cooler surface. This one was less cool because her spectacles gain heat from her hand. That was why there was less condensation on her spectacles. Understand? Now, explain why there's less fogging on Alice's spectacles. Again, a 2-mark question. So let's break it down into parts. First, understand what happened to her spectacles. Her spectacles gain heat from her hands, half a mark. So what if it gained heat? So it became a less cooler surface than Beatrice's, half a mark. Simple, right? Bring in the evidence that you saw and you read inside here and show your understanding in terms of heat gain or heat loss. So here is the heat gain part. And so what happened when it gained heat, spectacles gain heat, it became a less cooler surface. Then, so there's less condensation on Alice's spectacles because it's now a less cool surface. And that's 1 mark. Alright, next one. Explain why the spectacles became clear again after some time. This is also a very common question. It appears many times and which you will see later. So after there are water droplets that condense, after a while the water droplets disappear. Why? The surroundings, right, have heat. They're not in the air-conditioned room anymore. They stepped out of the car. Imagine they're in the car park. Alright, so it's warm now. So what happened when the water droplets on her spectacles gain heat? When the water droplets on her spectacles gain heat, they will evaporate. Basically, that's it. The water droplets on the spectacles gain heat from the surroundings, half mark. And then what happened? And evaporated, half a mark. Now, of course, at PSLE, oftentimes, for 1 mark question, there are no half marks. Okay? I'm writing down a half mark here just to let you know that there are 2 parts. But typically at PSLE, it's a 1 mark answer. So, when do you get a half mark? It could be if, right, the answer key provides the option or the leeway. Okay, you might have written just the water droplets evaporated, right? They might allow a half mark. Or maybe the answer is not as strict as mine. Because mine talk about the clear process of what happened to the water droplets. They must first gain heat before they can evaporate. Okay? Next one. Just 2 more questions. See, again, popular spectacle questions again. And this time, okay, again, air-conditioned room. Air-conditioned means now these spectacles must be a cooler surface again. A cooler surface. So now the thing is, now he stayed in the air-conditioned room, he didn't go out. So if you see in the air-conditioned room, by right your spectacles will not be fogged. But his was fogged. Why? Because when he breathed, as you're all very familiar these past few years, when you wear a mask, right? When you breathe out, air can come out from your nostrils, right? And it may go out through the gaps between the mask and your face. It can be from this side, or up here. So remember, what's his body temperature? 36.5 degrees Celsius. So the air that he breathed out was also warm air that he breathed out. And what is inside air that he breathed out? There's carbon dioxide, which is warm now. There's also water vapor. There's water vapor. This H2O means water, G means gas. Okay, so there's water vapor that he breathed out. Water vapor at his body temperature. So there's warm water vapor from his breath that rises up and touch the cooler surface of his lens. And what happens when water vapor touches a cooler surface? It loses heat and changes state. The warm water vapor from his breath escaped through the gap near his nose, half a mark, to tell us you know where the water vapor comes from. And then what happened to the water vapor? It touched the cooler surface of his lens, lost heat, and condensed. Okay, great. Into what? Into tiny water droplets. This half mark is for touch the cooler surface of his lens. This half mark is for the lost heat and condensed into what? Tiny water droplets. So never give up in trying to answer. Even if you get parts of it right and not the whole answer right, you still get parts of the marks. So don't give up, don't leave blanks, try it. Last question. Second last question. A worker used a truck to deliver blocks of ice. A mist was seen when the ice was taken out from the truck as shown. So this is an ice truck. Alright, so when they need to deliver some food that can go bad, like prawns or fish or meat. So they need to deliver it frozen. But how to keep it frozen? Well, it has to be inside a huge. This truck is a huge refrigerator. But when you take it out, right, you don't want this whole thing to be open. Otherwise, the heat from the surrounding will just be conducted into the refrigerator. It's that if you open the fridge door for too long, your parents will scold you, right? The things inside won't become cold anymore. If not cold, they will spoil faster. But you open it, so when you open, you need to like pull this is like curtains, There are curtains like this, all these rubber strips. So to access the thing inside, you got to push this apart, alright, and then grab the boxes inside. As you pull apart, you notice a mist coming out. But why is this mist? The word mist is used many times to always represent tiny water droplets. So when you see tiny water droplets, you know that there must have been a process of condensation happening. Condensation has happened. But where is the water vapor coming from for the condensation to happen? For condensation to happen, there must be a cooler surface and there must be water vapor. So now, your job to gain the marks here is to identify where the water vapor is, where the cooler surface is, and tell us to know, hey, I know there's condensation, but you must tell us where is this cooler surface and where's the water vapor. Because this is no longer a question like this, where the cooler surface is very clear, the lenses of his spectacles. Right, this is not as clear now as this. Okay, this is a less clear question, a bit harder. So how the mist was formed? 2 marks question. First part, tell us you know where's the water vapor. Alright, it came from the surroundings. Because the mist is only shown when he opened these rubber strips apart, push it apart. Half a mark for telling us, hey, the water vapor is from the surroundings. So what happened to the water vapor? It will touch a cooler surface. But what's the cooler surface now? The cooler surface is actually a layer of cold air that's inside the big refrigerator, which is a truck. Touch the cooler air leaving the truck. So the cooler air is like a surface of, it's like a cold surface. This cooler air. Half a mark here. Okay, I got a cooler surface, half mark here. Got a water vapor, half mark here. So what happens when this warm water vapor touch the cooler air? Well, you lose heat. Anytime the warm water vapor touches anything cold, it will lose heat. When it loses heat, it will condense into tiny water droplets. Half mark, half mark. There you go. 2 marks. Half, 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 half. And these tiny water droplets means mist. Remember I say this question? The mist disappeared after a short time. Explain why. Always ask this kind of question. Remember the previous one? Okay. This question about this Beatrice and Alice. Why the spectacles became clear again after some time? Same idea. The water droplets will gain heat from the surroundings and evaporate. So same idea here. The mist, which is the tiny water droplets, will gain heat from the surroundings and evaporate into water vapor. Next, thick plastic strips were hung at the door to prevent the ice inside from melting. Explain why. Now here it's about the topic of heat gain, heat lost, and talk about plastic. So let's make some connection. So plastic is a poor conductor of heat. So the plastic must have helped. So imagine here is the interior of the truck. This is the wheels of the truck on the road. And this is your inside of the truck. Remember, inside is cold. It's cold. And the surrounding temperature is much hotter. So here, let's say it's very cold. Let's say it's 0 degrees Celsius. But outside is a hot day. Maybe at 37 degrees Celsius. Oh, too hot. 34 degrees Celsius. Very hot day. So if you just open the truck up like that, sideways like this, open it up, well, the heat from outside will just be conducted inside through the air. So by adding in the plastic strips, which are the poor conductor of heat, that will slow down the heat transfer from the surroundings into the truck. So first talk about understand what is plastic. In the context of heat transfer, plastic is a poor conductor of heat. So what? So it helps to slow down heat transfer from where? From the environment to the ice in the truck. So the ice don't melt. Okay. Last question. This is from 2018. Now, John placed a packet of brown sausages wrapped in clear plastic from the freezer. Freezer, remember, underline. Even though it's not MCQ, you can still underline, identify the concept. Freezer is a place whereby they will turn liquid into solid, your water into ice. That's what a freezer does. So it's really cold. So it must be at or below 0 degrees Celsius inside the freezer. Then, of course, it was already in the freezer. So this must have been at 0 degrees Celsius or lower than 0 degrees Celsius. When took it out, after a short time, taking the sausage out, right, a thin layer of white solid. First time we're seeing solid. Always we'll be seeing mist, fog. Those are tiny water droplets. Now we see solid was formed on the surface of the plastic wrapping. So liquid only appears in a few things, right? There's water, vapor. There's water, which is a liquid. Alright, and there's ice, which is a solid state. This is a gas. So how did this water vapor in the surrounding, obviously must be water vapor, turn into ice? It didn't turn straight away. It turned to water first, then turned to ice. What's the process where the water vapor turned to water? Come on. Yep, it's called condensation. And what's the process where water turned to ice? Yes, it's called freezing. So in this case, explain how the white solid was formed. You need to give us these two processes. Tell us about the condensation. Tell us about the freezing. First step. For condensation, you need to tell us, you understand, where is the water vapor from? It's from the surrounding air. So what happened to the water vapor in the surrounding air? It touched the cooler surface of the frozen sausage. What happened when it touched the cooler surface of the frozen sausage? It will lose heat. Remember, we always talk about losing heat when the water vapor touches the cooler surface. When it loses heat like this, it will turn into tiny water droplets. Okay, 1 mark for condensation. And then tell us how did the water become ice? The water continued to lose heat to the frozen sausage. What happens when water loses heat? It will freeze and turn to solid ice. That is for freezing. Okay? That's your 2 marks. 1 mark for condensation, 1 mark for freezing. Now, similar question as before. After a while, the white solid cannot be seen. Why? Earlier on, it's about the mist on the spectacles can't be seen, the fog can't be seen. Now it's about the solid. So, just like before, now we must reverse the process. The solid must have melted to become a liquid, and the liquid must have gained heat and evaporated to become a gas. So, to get this 1 mark, you need to tell us these two processes. After a while, the ice gained heat from the surrounding. What happened? And melted. Into what? The liquid. Then the water gained heat from the surroundings. And what happened? And evaporated as water vapor. Then you get your 1 mark. Alright, I hope this helped you to revise your water cycle, change in state, learn these answers, always watch this again if you need help. All the best for your PSLE.